Hi, my name is Will Carrara. I'm one of the core backend developers for the OpenET project. I'm really lucky to work with some really great coworkers. Jordan Harding is our main kind of front UI UX designer for OpenET. Alberto Guzman, I think, oh, he's right there in the back. Also one of the core backend developers, put a lot of work into the API and the cloud infrastructure. So if you have any questions at all, they're going to kind of be floating around, circling, and they'll be able to help with any technical difficulties. So the slides for this are actually, I put a link in the documentation. So it's at openet.gitbook.io. So you can follow along. They're kind of interactive. So you can kind of click some of the links there and just follow along if you want to do that. That being said, we'll kind of get right into it. So this is the Data Explorer and API training. Really, it's going to be kind of a higher level overview. I'm going to kind of go through this so we leave a reasonable amount of time at the end just for folks to ask questions, or if there's any sort of specific development feedback, requests, feature requests, really looking forward to hearing those at the end. So we have a few things to cover as we get started here. So first, let's talk about, what is OpenET? What does the platform do? How do you access the data? We'll be going over the Data Explorer itself, this sort of front-end GUI that's kind of makes it a bit more accessible for getting kind of large-scale data in the Western US. The API, if people aren't programmers, what is that? How do you, build those bridges for third-party applications? That's what it's designed for. And then just a little bit about what's next. If you were in the previous plenary talk, we'll just have a few slides on sort of the farms tools and sort of the next things. That being said, so what is OpenET? OpenET, let's see if we can, the lights are a little bit bright. It's a large-scale platform to get evapotranspiration data out in the Western United States. Thanks, Forrest. We've really put a lot of time and effort into making not only this data freely and publicly accessible by putting it on the Google Earth Engine data catalogs, as well as building out an interface to be able to get that data out and sort of accessible for multiple types of end users. So what you're seeing here is just sort of that Data Explorer view where we're looking at regions, and then within that we've pre-computed field level data. And you're able to sort of click a field, see that 5 years plus the current year of data, and kind of look at just sort of at a glance like trend analysis. And it's really powerful. Pre-computed data isn't always the best. Many people have specific regions of interest they're looking in, larger aggregations of data sets. Some field boundaries aren't going to look as good outside sort of the Western larger agricultural areas. So that's why we have the raster layers in the Data Explorer. What this allows you to do is really just take larger subsets of the data, and maybe you want to plug it into some third-party GIS software, do some type of pixel level reduction yourself, plug it into a hydrologic model, et cetera. So whatever your sort of end goal is, we do support that. And so that's kind of where the raster end of the Data Explorer comes in. Getting right into it. So OpenET now has sort of a unified account system. So this is at account.etdata.org. If you don't have one, just go ahead and sign up. It's really easy. I recommend just using the sign in with Google button just because it makes things really nice. And so you can just create an account. What this allows you to do is sort of access all levels of OpenET. So whether it's going to be the API, whether it's going to be the Data Explorer, and now the farms tools, it's all running through this sort of centralized system. Profile is pretty rudimentary. You can fill out some profile information about yourself. You have the ability to change your password, delete your account. API keys, you can generate those here. So if you have any questions about that as we get into it, find Alberto in the back there or Jordan here. And yeah, so it's a really, that's going to be the system that we're going to be using just to kind of interact with the OpenET ecosystem. The Data Explorer itself, as I mentioned, is sort of partitioned into two parts. There's the pre-computed field summaries, where you have those boundaries kind of already provided. We've run those calculations, stored it in a database, and really you're just querying that database to get that information out really, really fast. It has those advantages of being able to do very large-scale aggregations. So you can look at large regions, get tons of field IDs. You can create maps from those boundaries. All of that's fully retrievable through the API. Really, really fast, really great for kind of looking more at those irrigated regions. If that's not the application that you have in mind, the raster API and the sort of the raster end of the Data Explorer is what's going to interest you most. It has the ability to sort of draw your own custom polygons, as well as just sort of click a point on the map. It's going to grab that pixel and then get the information for you there. So because I was a little unsure about how the internet was going to be here, I've just sort of automated these slides versus just doing a live demo just to make it extra safe. So this might be a little bit boring if you're sort of already familiar with the OpenET Data Explorer, but just at a high level, it gives you the ability to sort of search regionally where you want. You can both search an address as well as a longitude-latitude point. Select different years and different variables as well. And then toggle back and forth between the raster and field views. As well as you're going to see at the bottom here, sort of an opacity slider. This is really useful for just like grabbing really nice screenshots, to be honest. Or if you're kind of looking really closely to an area and seeing if those field boundaries are right, exactly over the satellite, base map. It's really helpful. And then the draw custom area tool, which we're going to get into a little bit later. So if you have this open, just click this point. It's going to take you exactly here. So you'll notice in like the URL of the Data Explorer, it actually includes the longitude, latitude, zoom level, some additional information. It kind of makes it easy if you're passing like a link to a coworker and say, I'm looking at this spot, can you click this field in the middle? You can just give them that URL directly and it just takes them right to that spot. So it's a handy little feature that a lot of people kind of overlook. Field view, really powerful. So first of all, as I mentioned, kind of that opacity slider, we can just sort of slide that down and we can see, okay, there's pretty good agreement for the region that we're looking at. Awesome. If you hover over the field, it's going to give you just the current year you have selected. It's going to pull that data really, really fast and just give you a little chart in the upper right-hand corner so you can, at a glance, just kind of compare fields without having to click and bring up the full graph. You can move those around really fast. It's really, really convenient. That being said, let's look at one of those fields there. So we can see that this was an alfalfa field. If you click a field, it's going to essentially grab the pre-computed data for that field for the last 5 years in the current year. Right now, you'll see that this is 2023. We're in 2024. We haven't yet pushed the update for that 2024 data just because like having a graph with kind of one point on it for like the raster view looks a little messy. So we're waiting just like a few more weeks just to have sort of a little bit more data in there for both the daily view and the having that kind of plug into the pre-computed geodatabase view. That being said, looking at 2023 here and previous, you can hover over these points and it's just going to kind of give you a nice tooltip that's going to give you the acre-feet calculation. So for the every polygon that you've selected here, it's going to have some metadata associated with it. It's going to have a crop type information. It's going to have the area of the polygon. It's going to have the coordinates of the polygon. These are things that you can directly retrieve through the API itself. So hovering over that gives you, again, that information at a glance. You can add multiple models here. So you're going to both see the different models from OpenET that feed into the ensemble, as well as the ensemble range, which is going to kind of be those upper and lower thresholds. Just as a note, you can also toggle over to see the cumulative view. This is really great because you can see sort of longer trends for an individual model for a region, and again, it's so lightning fast, which is really nice. So if you see maybe a deviation for one of those years, sometimes you'll see a field that maybe volunteers for like a voluntary fallowing program, and so you can see a very clear dip in the evapotranspiration, for a particular year outside the others. So this is just a really fast way to just kind of at a field scale get data really, really quickly and easily. There's this download data button. So it's a little small. I know some people overlook it, but if you want to get this data out, you can both get PNG images of the graph, JPEG images of the graph. You can download a CSV of the data that is displayed there. There's a nice little feature that I don't have showed in here, but you can actually click this graph and it's interactive and you can zoom into a section of it. and kind of highlight a particular region. If you hit download data, it's going to only grab the period that you have zoomed in and viewed. Because sometimes when you're looking at like daily data, it's really messy, like kind of looking, or that 5 years is a lot of data to look at. So you might just want a section of that. So that tool does segment properly. Raster view. So field view is pretty self-explanatory. The raster view gives you a little bit more customizability at the trade-off of a bit of speed. So these rasters are pre-computed, but all of the pixel reductions are done on the fly, and that's done through the API. So instead of just retrieving this, it's going to be calculating, whatever your request is. So again, this view allows you to just click a point. Each of these pixels are 30 by 30 meters. So you click that point in the middle of that field, you're going to be able to retrieve data. So raster view is going to be what gives you the closest to real-time data. You'll see that it will shortly go into 2024 for the daily, as well as have daily data. That's the thing. It's really storage expensive. So for the geodatabase, that's only monthly data right now. We're looking at doing potential expanding that to daily, but it's just a lot of storage space. So we're keeping it in the raster view for the foreseeable future. That being said, it's really easy to interact with. It's the exact same interface. And again, you can sort of, for this daily data, for example, you can toggle different years. So in this case, I'm looking at 2023, but I want to look at 2022. And you can see how the data changes. And again, all of that data can be just completely downloaded quickly just from this interface. Yes, you have a question?
So in the plenary, they were talking about the Landsat 8 is an 8 or 16-day return. So how is this daily data generated?
Great question. So from the overpass scenes, it's going to be a little hard to answer. So we're looking at each model has the reference ET as an input. In California, there's a state product called Spatial Simus that's used. It's a daily reference evapotranspiration. So it's kind of the ET over a theoretical grass surface. And then GridMet is used for sort of the rest of the US. So in the Data Explorer, if you clicked in California, you're seeing the Spatial Simus. If you click outside, you're seeing the GridMet reference ET. From the satellite observed scenes, so let's say 2023 had maybe 50 observed scenes or so. It's going to vary depending on the region you're looking in, depending on the cloud cover, et cetera. So you might have more or less scenes. As I'll talk about a little bit later in the forecasting for February, there's very little data right now to do this interpolation, so it's very heavily biased on the reference evapotranspiration. But what it's under the hood, it's looking at those scenes, it's calculating an ET fraction, and then multiplying that times the reference evapotranspiration and doing a pixel level interpolation. I can get into the more technical details of how that's done, but that might be a little beyond the scope. Just come find me after. But yeah, it's a pixel level interpolation code that's kind of running through this.
Can we ask questions while you are teaching, or do you prefer us to wait until the end? That's my question.
I don't know. I don't know if people have a preference on that. To be honest, I think we're going to be maybe. Yeah, I think it's kind of nice to be a little bit more interactive, just because I'll be covering so much material. So please feel free to ask questions. Yeah, please. Yeah.
You have a nice clear image. One day all the pixels are covered. Then a month later you have an image with half clouds and half not clouds, and then you have another cloud-free pixel.
Yes.
Is the interpolation done pixel by pixel? So in other words, for every pixel it is checked where are the cloud-free pixels, and that then is used to do a linear interpolation between all the different images. In other words, if I would do some work in Louisiana and I have for 3 months no data, then you would have one straight interpolation from that between the two images that are 3 months apart. Is that correct?
Yes. So,
And it's pixel-based. It's linear interpolation between cloud-free observations for each pixel. And then what we're doing currently with the daily data is taking the last cloud-free observation and extending it out. We're working on improving that. And Will has some really nice short-term forecasting product that it can especially as we produce the long-term historic archives, those forecasts are gonna get better and better and better and better. And then I think Will's gonna talk about bringing in some of the gridded meteorological forecasted data so that we can produce the ETO forecast as well.
Yes, and just one quick add-on to that. There is, like, internally in the code, it will look for other scenes, relational scenes, depending on like some type of temporal difference of whether to include those pixels. So if you're looking, the last cloud-free scene is 120 days ago, it's not going to include that pixel, and it's just going to linearly interpolation. But if you have a really close, scene to use, it'll kind of plug that in, so within a certain like time threshold. But yeah, great question.
Thank you.
And I have one question.
Please.
So you mentioned, I wrote down, I think, right, that you could actually send the hyperlink of that field to one of your, so I work with citizen scientists, and we're trying to work out a way in which to look at parcel-based water use for conservation. And let's assume that each field, there could be multiple field level polygons in each legal parcel.
Okay.
That then, let's say, is contracted for water, and that water is metered, and now we want to assign those fields to someone to ground truth.
Sure.
And to understand and come up with a water balance for that, and
Yeah.
the way we're talking about, is this platform, or is that polygon, can I assign that, all of the fields in the polygon to a certain citizen science? So you don't have to answer that now, or
The short answer is the farms tool is going to be exactly what you need. So there is like sort of the ability to have multi-polygons. This is supported through the API currently, and you can within that sort of spatial region assign multiple attributes. So you could have ID 1, ID 2, some unique ID for every polygon, and then maybe a secondary attribute of like block 1, block 2, where multiple polygons are assigned. So with farms, you'll be able to sort of easily do that at a high-level GUI. In the API, you could do that now and send that data to those citizen scientists, and they could just bring that up really quickly and sort of find out. Yes. Yes. Oh, yes, sorry. So it's openet.gitbook.io. It's the documentation for OpenET, and you'll see on the bottom left, there's a conference slides that should be linked there. Well, yeah. If anybody's having trouble accessing those, let me know. Yeah, sorry, openet.gitbook.io. Yeah, it was a little easier to just do that versus sending like a large email to everybody. So apologies, it's a little bit more. You have to go one extra step. Yeah, sorry, depending on your laptop, tablet, however you're accessing this, you might just scroll down to the bottom left. You'll see it on that menu at the very end. Yeah, that will be useful later if you want to do some more of the interactive API slides. But just kind of for the sake of time, I'll be kind of covering the Draw Custom Area tool here in the Data Explorer interface. So at the bottom right, you'll have seen that sort of big Draw Custom Area button. This just is going to allow you to draw a single polygon within a certain spatial threshold that's going to sort of reduce all of the pixels within that region to the mean aggregation. In the API, you'll have some more options, min, max, median, etc. In the Data Explorer, it's taking the average of all of those pixels and reducing them. So it's a really easy tool to use. You can, sort of either directly draw a square or use the sort of multi-selector in the upper right to just kind of draw the region of interest, and it'll give you the area, and you just hit Run Time Series. On a side note, this is really useful for when you want to get like the geometry of a region, because OpenET, Earth Engine, and all of these geospatial platforms actually take longitude-latitude format versus lat-long format. You'll see that there's this copy the shape to clipboard that automatically formats it for you and gives you the geometry. Very, very useful. Again, for producing kind of reproducible results using the API, for example. So as I mentioned, you're sort of taking an aggregation of all of the pixels within that region. And again, same exact interface as the point and the geodatabase calls, where you can just select multiple models and you'll get that data output in that way. So that's kind of all I had for the Data Explorer, like high-level overview. Are there kind of any questions just sort of on that interface at all? Oh, yes.
Just a quick question. Is there any way to see how many data pixels that we have that's logged when we are seeing the time series, the daily time series, for example, for a specific cloud?
Sorry, could you, how many what pixels was that?
How many data pixels that are included for calculation of
So at this time, you're not able to see that information. So the question is, if you're kind of looking at daily data and you're looking at a region over time and you want to know how many cloud-free pixels, there are some metadata endpoints in the API which can give you a little bit closer towards that information. But right now, I don't have that accessible. But I've heard a few requests from folks that that's something that people are really interested in. One thing you can do is there's a parameter called overpass that we'll talk about later, that if you set that to true, it just gives you the non-interpolated, just seen observations themselves. So you can kind of pull those and sort of look a little bit more visually. Not a great answer right now, but it's something that I plan to build in after this.
Yeah, so you could write a Python script to just pull the full time series and then just the ones for the scene overpass dates. That's a little messy, and then the team will be talking about additional metadata layers and products to add to the archive tomorrow afternoon, and so that is on the list.
Wonderful. So I'm going to kind of switch to the API overview. So before I get into this, if just by show of hands, how many are sort of developers, coders, sort of familiar with things in that space? Okay, wonderful. A lot of you are wondering, what is an API? So APIs stands for Application Programming Interface, and it's sort of that intermediate thing that's kind of between the server and between the front-end application. It's gonna, when you click something on the Data Explorer, it sends a request to the API. It does a lot of the processing, and the API communicates with the server, talks to the CPU, does these things to get that data processed, and then it sends it in a nice clean package to the front-end interface. And that's how basically the modern web infrastructure works. There's that front end, that middle end, and then the back end. So APIs kind of are more on the back end of things. There are a few types of requests you can make to APIs. So sort of the standard ones are, I can make a GET request to give me something, a POST request to also give me something, but in a slightly different way, PUT request to update something, a delete request. We're going to be, just for the purposes of this, just kind of covering the very basics of GET and POST. All you need to know, and I've provided the code for you, just if you're a little bit unclear on interacting with those, is that they are basically just two slightly different methods of just getting data from an API. So at a high level, that's kind of what it's used for is, you want large amounts of data out in an automated fashion, you're going to interact with an API on some level. So that's what OpenET has. There's a few different types of endpoints that OpenET supports. So just the layout of these slides are kind of fun. So if you click the bottom left here, it's going to take you to the documentation for OpenET's API, and it's going to take you specifically to whatever the endpoint that you're viewing. So in this case, I'm looking at the account endpoint. There's some really useful things here. Just sort of example curl requests for making things directly in a terminal, Python code for just making those requests in Python. So the documentation is really going to be the first source of how do I do something in an API, and in this specific API, this will be where you go. Additionally, you'll see that there's going to be a console button. So because there's a lot of non-programmers here, and we want to support being able to get automated data retrieval out, and sort of maybe it's your first time, we use this interface called Swagger UI. And what it is, it's a high-level interface that allows you to make requests really easy, just kind of clicking around. So for some of these, I'll be going over them and sort of showing you, hey, there's this pre-filled request. You hit try it out, and you hit run, and it's going to give you that data exactly how the API would give it to you. And then you can write the code, to interact with that. That being said, before we get into these sides, you're going to want to go to account cloud.etdata.org. You'll just sort of select what your sign in. In my case, I just usually use the sign in with Google. Accept the scopes that it asks you to do. This is going to be things like, if you have your Earth Engine account linked, can I use that? Things like, can I write to your Google Drive to a specific folder? So let me just bring here. So on the account page, we're going to need an API key to be interacting with these things.
Well, maybe pause for 1 second and
Yep.
just talk about why we need to write people's Google Drives.
That's yes. Sorry, thank you, Forrest. In some cases, we provide 2 ways to export data, or 3 ways really. One is going to be directly through the browser itself. It'll just return the data directly, and you don't need to do anything. It's really easy to work with. The second way is I have a lot of data, and I can't return that through the browser because it'll break the browser memory limit. So we allow the sort of exporting to a Google bucket system that OpenET fully manages. It's a private bucket system, and then it turns it into a public bucket, moves to a public bucket when you want it, and it lasts a day, 1-day life cycle, and then it just goes away. There is the ability to encrypt this data using the encrypt parameter if you're interested in doing that. It's a little bit annoying to deal with, honestly. I don't see a lot of people use it in the community, but you can do that if you want. The third way is, well, I don't really want to interact with Google Buckets, and I don't want to be in that main OpenET queue. You have the option to link your Google Cloud project and existing kind of Earth Engine account. If you do this, it's sort of giving OpenET access to that sort of a few components of the Google ecosystem. So specifically, the scope that you accept is, can I create a folder in your Google Drive called OpenET exports, and can I write to that folder? And so it's just sending the data directly there. At that point, can't touch it. It's gone, it's sent, and I have no way, unless I know your Google Drive password, to get in to modify it. So it's just an easier way that a lot of people prefer when they're doing large amounts of data processing, is just send it to my drive, and then I can just link it and send it an email. It's up to you on how you have that linked and exported. I will be adding the option shortly, based on a very popular request, to send exported data to a bucket, even if you have your Earth Engine account linked. Right now, Earth Engine account linked, Drive not linked, Google Bucket. Yeah. Yes, question.
Is OpenET API another way of doing things that could be done with Google Earth Engine, or are there differences? In other words, why would I use OpenET API if I could do things with Google Earth API?
Yeah, great question. A lot of the things can be done. The OpenET API is built leveraging a lot of the Google Earth Engine API. The limitations you're going to run into are going to be that some of the data sets are not yet publicly accessible on Google Earth Engine. For example, the scene assets for daily data, those currently are private collections. We're working on getting those publicly available. You'll notice in the public Earth Engine data catalog that there's going to be data from monthly data for 2016 to 2022. We're looking to update 2023 to that. So currently, if you were in the Earth Engine API console, you can't access that 2023 data or the scene observations. A lot of the other things that I'm showing you can be done, and that's how they work under the hood in the API. Just because Earth Engine's a really powerful spatial computing platform. I mean, credit to those engineers, because it's nothing short of magic being able to do those levels of pixel reductions on those scales in the speed that they're being done. Yeah.
Yeah, for large-scale scientific analysis, we would definitely encourage folks to use Earth Engine if they can. And then if you want sort of for application development, we're usually
Small
doing
enough.
smaller subsets for some recurring application in the API, or something really quick for someone who is not an Earth Engine user, who just want to pull that data down from irrigation district, or get some geotips, then the API is there to be even more user-friendly.
If we develop something that is then shared with OpenET, and let's say it's more, higher resolution than what's available through OpenET.
Sure.
So we, as citizen scientists, share it with OpenET. Will it be available only through OpenET, or will it be made available through Google?
So I want to make sure I understand your question correctly. So if you created like a new image collection or new raster assets, you can put those on Google Earth Engine itself. So those, it kind of also then has a nice benefit of serving as sort of the like a drive for geospatial things. So you can store image collections, shape files. You can store different things and interact with those. So if you wanted to interact simultaneously with Earth Engine and the API, you could do that in Python, calling the API for certain things, and you could have it call Earth Engine for certain things and just sort of coalesce those data sets. If you're just purely in Google Earth Engine, you could just do everything through that JavaScript console there and just kind of have it all play nicely there. You can export OpenET data, put it up there if you wanted as well. So there's a lot of ways to sort of harmonize the different things that you make with the API with any other existing or ancillary data that you're using outside of OpenET.
But it's not automatic. Our default assumption is everyone wants to keep their own data private. So it's up to you. So you would need to take the extra step to then make whatever a public asset on Earth Engine in your account. So our default assumption is everyone wants to keep things private, and that's how we manage the data for each of the users.
That's the question.
Yeah, again, and this is default of Earth Engine. If you upload something that's private to your account, you have to go and hit the share button to either share it, anybody can read, give it specific access to a certain email or group. That is just one additional step that you'll need to take, and I'll be talking a little bit more about that shortly because we'll be doing that for some of the endpoints that need access to Google Earth Engine. So back to just quickly the account system. Creating API keys is really simple. You just select this box, you give it a name. I'll just say this new key here, and then you just hit create key. And then you'll see that that's created. You could at any time edit the name, view the key, delete the key, etc. So in this case, I'll take this, I'll copy it to my clipboard because I'm going to need it for kind of these next steps when I'm interacting with things. Yes, question?
Do those keys have a lifespan where they're only going to last for a month and then we have to create a new one every time we need to do something?
Currently, there is no time to live on the keys, so they last indefinitely at this time. We plan to introduce in a future update like a 2 year expiration date. In general, it's not super great practice to have like an infinitely lasting API key, so we will be introducing like a 365 day. But
For application purposes, would you need to renew your key every year or something like that then for that reason?
yeah, and we're gonna look into providing like an automated way to do that. Just because if you really want that fully seamless application, it's just kind of nice to do this through code. But at this time, those keys do last forever. So share them wisely. But if you delete the key and you try to use that key, if it leaked for some reason, it's invalid. So you can fully manage and delete those if one of them ever leaked for any reason. Yeah. So just back quickly to the format of the slides. You'll see a third link here to Google Colab. Colab, if you're not familiar, is a really nice platform for just kind of sharing code universally and just having interactive environments that are in the cloud. So you don't need to mess with like going to my local computer, installing Python, setting up an environment, doing all these things. It just kind of automatically does that for you. So we'll be going over a few of these really quickly as well, just for the code end of things. But before we do that, I am just going to kind of mainly talk about just some of what these endpoints do, what their purpose is, and just how to interact with them quickly at a higher level. So there's the account status endpoint. So OpenET is broken up into three categories of endpoints. There's the account things for messing with your OpenET account, the raster endpoints for messing with raster data, and then the geodatabase endpoints for doing things with geodatabase type of endpoints. In the future, we'll be doing experimental, which will support like kind of the farms tools and other things to give sort of public access to that. But right now, it's just kind of those categories. Account status, all this does is it allows you, and I'll use the interface here. Oops. It just gives you information on your account. So in this kind of Swagger UI, there's a button in the upper right. just says authorize. This is where I'm gonna paste my API key in, and I'm just gonna hit authorize. Once I do that, I can interact with Swagger, and it's gonna use the cache of the web to sort of remember that key, even if I refresh the page. Mine might look a little bit different from yours, just because I was gonna use my personal account, but because I'm using a different computer, I'm just using my admin one. You'll just see some basic information. So if I can zoom in. It's a little easier to read. Right now, just some really basic things. Information about sort of monthly quotas, the tier that you're on, how many requests you've used. You'll see, as I mentioned in the talk earlier, that there's going to be, if you have your Earth Engine account linked, an expansion of your quota while that is linked. Ignore the fact that mine says none right now. Yours will either say 100, or if you have your account linked, it'll say 200. Yeah, so you just use this to sort of check information about, how many things am I exporting, et cetera, just because there are some inherent limits to the API itself. And we, are trying to support a large community with sort of limited service account resources. Yes, question?
Are you going to go through how to limit the Google Cloud project ID?
Yes, I will. That being said, if you want to do that, you need, say you have an existing Earth Engine account, and I'm struggling to remember the URL for Google Earth Engine, their code editor. Is it? Yeah, I think it's code. Oops. It's very funny when you switch to a different keyboard, like your memory is very off. It's not code dot. Ah, thank you. Code. Sorry, I have all of these like permanently linked on my computer, and so I haven't had to type a URL in like years. It's a strange feeling. So here you can see my account. There's some. So if you're not familiar with Earth Engine, I highly recommend you sign up just because it's free. They do have kind of commercial offerings if you're doing something really large scale, but it allows you to sort of write these scripts, store assets that you want, as well as just kind of do large scale geospatial processing. If you want to link your Earth Engine account, you're going to need to, if you register a new cloud project, if you don't already have one, you can see I already have one called OpenET here. I can just click that, get some basic information. What's important is the cloud project ID. So once you've created yours, it's really easy. It walks you through like 3 or 4 clicks. Very simple to do. You just take that ID, and you're going to be plugging that into this thing right here. So in your profile at the bottom, it just says Cloud Project ID. Hit save, and you are linked. That being said, there's some nice advantages to doing this. You are on your own queue. So if you run a task, an export task, you'll have control over canceling it. You're not going to be in line with a bunch of other people. You'll be using your own account. Really nice benefits to that. So back to just kind of covering some of these endpoints. Account status, really helpful. It shows you information about what's going on with your account. The storage endpoint, which I'll go over in a little bit, is going to allow you to retrieve exported data to the bucket. So if you're not linked and it's not going to your drive, it goes to the Google bucket. This just makes a request, and it grabs those files and just lets you retrieve the link directly. The raster endpoints. So the same thing you saw in the Data Explorer, they're just calling this directly. Time series point is pretty simple under the hood. It takes a few parameters to use. So if I wanted to look at this region right here and I want that point, I'll take the longitude, latitude, and you put it into a little geometry string. So the parameters are a date range, some period that I'm looking at, interval, daily or monthly, overpass. This applies if I'm looking at daily data, and if that's true or false, it'll give you just the scene overpasses. File format, do I want a CSV data? Do I want JSON data? What do I like to work with? Models, the specific model of interest. At this time, the raster endpoints, it's a single model and a single variable combination to get data. So if I were to take this and I go with so many tabs open, let me close these. And I go to that user interface here. I can just retrieve data for a single model and single variable. So here I can, again, it allows you to sort of quickly change these. Let's say I want data for 2021 instead of 2020. I can just modify that. I can take my point, put it in here. I like JSON data. It's easy to work with. Monthly, your data, just so it's on a monthly aggregation. What model you want. Maybe it's Ensemble, Sims, PTJPL, Dyslexia, et cetera. Units, whether you have that depth of ET in millimeters or inches, the variable that you're interested in, and then your reference ET source, so kind of what's plugged into the model based on where you're looking. California does CIMIS. You can use GridMet in California, nothing wrong with that, but that's just one of those parameters that we allow you to feed in. Yes, question?
For those parameters, is there documentation somewhere that reminds users that you do millimeters and inches?
Yes, so that being said, I'm throwing a lot at you right now. So for each of these, there's a full set of documentation that explains what the optional parameters are for the OpenET API, what they mean, how to use them, etc. I'm going to be kind of a little bit quick going because I'm running out of time here. But if you hit the API reference and you scroll down a bit, you'll see the optional parameters. So these are the accepted parameters. The ones that are required are in bold. They're the ones that have a default parameter are in bold here. But this tells you exactly, what models to choose from, what are the variable options for, interval, and it's just a quick way to look here. That being said, if you have any questions, if any of those don't make sense, just come find me and I'll happy to explain those. Yeah.
Is there any documentation on the different models?
Yes, great question. So if you're not like me, I'm more in the software engineering world, less on the environmental science end of things. You're gonna want to know, do I use Dyslexia or E-metric? What's the difference? Where do I find that information? So on the main OpenET website, there's a models and methodologies page that's going to have a description of each of those models, as well as kind of different, some kind of strengths and limitations, and that information is found there. Yeah, it's much better of an explanation cited there than what I am able to give you, unfortunately. So yeah, the Swagger interface, really helpful, really quick just to be able to use. It gives you an example curl request. So right here, I could take this and plug it into the terminal of my computer and run it, and it's that fully formatted request. From a developer perspective, things to note, you'll see that in the header, that's where you put your API key under the authorization keyword. If you're not a developer, don't worry about that. And you'll see here the output of that query. Swagger is really nice because I can just hit download, and it's just going to download that data directly for me. So it allows you to really quickly iterate, play with, sort of look, kind of understand the API at a high level if you're not as familiar with coding. So that's what the Data Explorer endpoint calls when you click a point. It's just calling this endpoint in the API, and that's how it works under the hood. Same with the Polygon endpoint. So pretty similar idea. The parameters are almost identical. You'll see the addition of this, of two things here. So you'll see the addition of what's called a reducer. All that is saying, when I have a region I'm interested in, and I want to look at all the different pixels within that region over time, how do I want to sort of combine that into like getting one number out? So the Data Explorer uses the mean aggregation by default. Most applications end up using just sort of taking the average, but you can do things like take a sum of all of those. You can take a minimum, a maximum, etc. So the API gives you a bit more flexibility than what you're seeing on the front end of the Data Explorer. So that's what that reducer parameter is. You'll also note that there's two things here for geometry. There's geometry and asset ID. Typically, you're going to just want to use geometry for the time series polygon endpoint. Asset ID allows you to define a feature collection or use a shapefile as an uploaded Earth Engine asset. So I can talk a little bit about that when we get to the multi-polygon endpoint. It'll make more sense. But you can actually enter that in place of geometry for most things in the API. It's not well documented, but it is built in. Multi-polygon. Similar principle. This is kind of what Farms is leveraging, is where you may have multiple regions of interest that you're wanting to spatially aggregate and compare. So multi-polygon is really great for this. You'll see that it's in the actual API, there's the time series multi-polygon and the export multi-polygon. That might be confusing, and I'm sorry the naming is not great. We have a series of endpoints that just return a really quick time to live link from Google. So it's like I think it's a 5 or 15 minute link that just, when you run it, it grabs it in the browser, it runs the query, and downloads the data instantly. It's sort of like an in-between of getting the return directly in the browser versus exporting. It can handle like kind of semi-large regions, but it's just really kind of useful if you're looking at smaller regions of multi-polygons. If you want to do larger analysis with the API, the export series of endpoints is what you're going to want to use. And we can talk a little bit about that coming up. That being said, you'll see that this is really similar to the Polygon endpoint with the substitution of geometry. Sorry, that shouldn't say geometry. It'll just be asset ID there. It's a typo. That you can use. So if you wanted to use this endpoint, you can upload shapefiles to Google Earth Engine. So because I'm not using my personal computer, I had kind of other things set up for this, so I'm just going to talk you through it. There's an option here in Earth Engine to upload a new asset. So if you click this, it'll give you the option to select source files. So you could do, of a shapefile, you'll have like 5 or 6 different things, DBF files, a shapefile, etc. And then just create an asset name for these. Once that's done, you'll see that it'll take a few seconds to process, and over here in the upper right, it'll like have a little loading icon that says, loading your shapefile, and then you'll see that it appears on the left here of your projects. So here, for example, I uploaded a sample training file. And so this was just the one that you've probably seen a few of already, where it's 5 polygons. You can click this, you can see just some basic things. I have a block attribute, an ID attribute, etc. The thing to note here is that I need to hit share, and I can either share with OpenET at googlegroups.com specifically, or if I'm just lazy and I'm just gonna hit anybody can read. And that just allows us to take those geometry coordinates and be able to use them to sort of cookie cut out rasters and do the operations that the API does. We can't do anything other than that.
Will, it's worth mentioning that if you share with us, the only thing we'll do with that shapefile is use it to run your queries.
Mhm.
We can't really read it or do anything with it. The only thing we're going to do is when you submit an API call, pass that shapefile in to run the query and return the data. That's it.
Yep. So yeah, that's kind of how you're gonna sort of the small part of here of just kind of interacting with Earth Engine just to get this done. The table ID, this sort of asset ID thing, the name's changed a few times. This is what the API is going to take as an input parameter. So I can take this, and I'll need to know every polygon needs to have some unique ID. So if I were to go over to this kind of Swagger interface, I can look at this, and I'll see, okay, I want to change the default thing that I have in here to that specific shapefile. I could paste that in. The attribute is also coincidentally called ID, but you can include multiple attributes here. So that other one had the block attribute, so I want to include that. The only thing you have to include is the unique identifier for every polygon. So if you don't include that, if a polygon exists without an identifier, it won't be included in the export, just because the API, from the API's perspective, we don't know it's there. And again, date range, monthly, interval here, model. Again, feel free to plug and play with this. The nice thing about units is if you do millimeters, you'll see that this export file is going to actually have the area and volume calculations, and it'll be specific to what you've chosen. So in this case, I selected millimeters. And when I take this file and I hope this computer has Excel, I will be able to see both the area and volume calculation for this. Yes, we're in luck. So what does that output look like? Here it's really simple to work with. You can throw this in like a pandas data frame if you're a developer and do like data processing that way. You'll see that for every month time step of the range I selected, you'll see for every polygon unique identifier, as well as whatever respective block attribute it has in this case, you'll see the ET value, the area of that, and then the volume calculation respectively. So multi-polygon endpoint just tries to do a few extra calculations for you, since we know most people are ultimately going to convert this into a volume, so we add that in there. Let's see, we're running a little low on time. Yes?
So 1/1/2019 means the month of January?
That's correct. Yeah, be careful. Excel sometimes like formats the dates for you in weird ways. So depending on how you might have it configured on your local system, you might see that look different. But yeah, it should be some, I think it's like ISO 8061 format is the way that the API should put it out in most cases.
Yes, that's the month beginning on January 1st.
Mhm.
Yeah.
So yeah, using this, it's really nice because I can just get multiple polygons out really quickly, kind of do larger scale data analysis. Back to the slides here. You might not want us to do all the, oh, sorry, there's a question.
So regarding the previous request, the
Yes.
link that you generated, is there any expiration time for that? The link is going to be available for 1 hour or?
I've seen it change. I think it's around 5 to 15 minutes now. I'm not sure what end of that, but it's one of those two. They've kind of changed it in the past. So try to grab it immediately.
After generating the
Yeah. And I have some code in here as an example of how to do that, and it just reads it directly. So just moving on, if you maybe not, you don't want that numerical output and you want the raw raster data. Maybe you have a model that's going to be feeding this in directly as geotiffs. The API is a really nice way to kind of get stacks or composites of rasters out directly. So in this case, I'm just kind of going to look at this region right here. Again, you'll see that the parameters are really pretty much identical across the board. Some type of temporal range, some type of way to spatially define the region of interest, whether it's geometry or an asset ID that you have, and then your variable and model combination. So the raster export stack, for every month, it's going to give you an image. So if I requested a year of data, I'll get 12 images back, and it'll give you those raw raster geotiffs. For the export stack, you do have the option to use what's called a pass cog equals true, and it makes it the output a cloud optimized geotiff. In practice, that's not really useful for most people, but just note that is something that exists if you're doing like a lot of work in the cloud. It's slightly more efficient for those types of applications. So getting raster data out, it's really simple. It's pretty much the stack and composite endpoint. Just a note on exports here, because I do want to save some time for questions. The export multi-polygon. So what these do is it will either export to your Google Drive or to your cloud bucket. So if I export this, I'm going to run this endpoint. Again, it's pretty much identical. I do have the option to give it like a drive folder if that's something I'm exporting to. But I'll take this kind of pre-filled query and we'll run it, and we'll see that this is going to give us just sort of a different output. So in this case, my thing is linked up, so it's going to my Google Drive. If I'm really quick about it, I can actually see that right here in my personal task manager, I'm seeing that this is being run, and I could cancel that if I wanted to do that. It's kind of the power of having your cloud project linked. If it's not, you'll have the ability to sort of track this when it's done. So if you're perhaps using the standard OpenET account already, you don't have your project linked, you want to know when is your file done, because it's going into a queue with other users, and they're just going to be run about 4 jobs at a time. So you don't know when it is finished, but you want to know. The tracking endpoint just allows you to take the tracking ID, and it's just a simple GET request here. I can plug it in, and I can say, whoops, tell me what's the status of this, just like you would do for like a UPS package. So this, I'm curious if this is going to load. This
GPS, it tells you last seen loading in Chicago.
Yeah. Well, just a quick note. The last couple days, Earth Engine has a bug where one of their the E-list operation is actually not working. So if this loads infinitely, that's something that I know they're working on, and that was prevalent the last like 2 days. So kind of bad timing for the conference. But normally it would return just a status that says pending, waiting to be submitted, succeeded, it's done, running, actively being run, or failed, and it'll give you the reason why did it fail. You can make things fail in this. So once you send it off, you could have some crazy complex vertice geometries that intersect each other or do weird things. Here we go. Yeah, it's currently running. If you see that failed status, most likely the input geometry you've used, something might be wrong with it. Like double check that there's not some infinite type of situation happening. So if you see failure, shoot an email to myself or the support at openet.data.org. So just gonna kind of breeze through this. So I'll see that file in my Google Drive in this case. Yeah, tracking, covered that. So the geodatabase endpoints, I'm gonna just breeze through these. Geodatabase is really cool because it's really, really fast and you can get like a lot of data out really quickly. It kind of works in 4 ways where you have some region that you want and you want all of the IDs for every polygon associated in this region. So in this case, I've drawn some box and you're gonna see when you actually query that, you'll see that it's gonna return IDs for everything that's there. So just kind of a quick note that sort of right here, I'm just barely clipping this geometry. It's going to include that ID, so be careful how you draw your box. You might get additional fields in there. When you have the IDs, this is how the rest of the geodatabase endpoints work. They take a list of IDs, and they give you information back for each of those IDs. Every polygon has a unique ID. In general, they don't ever change. In some cases, and we'll let the users know if there's a large update to the geo database, those IDs might change and you just make that query again. We do support properties query. So this just gives you a list of attributes for the IDs that you've provided. So you would see things like what are the CDL codes for the different years. So that's the cropland data layers that you can say like, oh, this was alfalfa for 2016. Then they decided to do soy for 2017, et cetera. You'll see the area of that and just some other useful properties that you might want. The boundary query is you want the geometries. So that's a really powerful thing about the geodatabase is having these geometries available. We do support retrieval for kind of small subsets of these. So you provide a list of IDs. It's going to spit out a GeoJSON of those geometries. So really quick in practice, what does that look like? I have some geometry. I take this, and it's going to spit out a zipped GeoTIFF file, or a zipped JSON file. So the API, because you might make a query that has like 10,000, 20,000 field IDs, and then I need to return time series for all of those for like multiple years, we do compress these outputs. So you would just hit download, and you can just see here. I usually use Mac and it automatically unzips, but I added the code for unzipping it. Yeah, so at a high level, yes, so go ahead.
Back to the previous one.
Yeah.
I'm thinking of this question of multiple parcels, and you want to know which fields are associated with those parcels. With this overlap intersection here, you could easily have 2 neighboring parcels, and the list of field IDs is going to include the same field twice, right? Like 2 neighboring parcels, and that circle is going to be overlapping with 2
Correct.
Is there any idea to say, like, give me the center point of each field, and so it's a point overlap, so that will only overlap with one parcel that includes the center of that field?
You know, in an earlier version of the geodatabase calls, we had that option to sort of specify the type of intersection that you want. I ended up taking it out just because it was kind of bloat, but that's something I can add back in. At this time, no, and you just take those lists and like filter distinct and decide what group you want those IDs in. But that's something I can add in. Yeah. Okay.
I think that would be useful.
Nice. Awesome.
If your asset IDs identify each field as associated to a parcel,
Mhm.
then would that do no matter?
Yeah, so if you were doing that type of analysis and you had those boundaries, you could have a specific set of attributes in the multi-polygon endpoint and just make the raster query that's going to give you those subsetted exactly as you would want them to be. That's a good point of another way to do that. You'll see that there are different ways to achieve the same outcome with the API, just because its inherent design was supposed to be really modular. So you can kind of accomplish the same task a few ways, often cases. Just to leave a bit of time, I'm not going to go over, just because I know we kind of have a smaller handful of coders in the room, but each of those examples most of them have some kind of interesting things in them. There's some stuff on anomaly detection and just kind of looking at deviations with time series data. So there's some nice useful tidbits in there if you want to take a look at those Colab notebooks, and if you have any issues running them, let me know. So just to kind of talk about what's next. We did tease farms in that other talk. So if you want to use the multi-polygon endpoint and you don't really want to do any of the coding aspect of this is what farms is going to be used for. Right now, you'll see that the system itself might be a bit buggy, because we wanted to develop enough of it to have something that people could use and test with, but not do so much of it where we can't really integrate the feedback of what people actually want included in there. So that being said, as I talked about earlier, there's a way to draw polygons, select existing polygons, upload your own shapefile, and again, under the hood, now you know, this is calling the multi-polygon endpoint on a loop. At the time of this, and I didn't cover this there, you'll see that it says, enable recurring report. Once we kind of get through a little bit more of a beta phase of this and we dial in exactly what these reports should look like and include, you'll have the option to just say, every month for the next 7 months, send me a report, and it's going to have all this information fully automated for you. Farms is really, really powerful. And you have Jordan right there to thank for all the front-end UI design and making all of this work. So if you have questions and features and functionalities and wants, he's a great person to talk to at the conference. The other thing I'll quickly touch on before I answer your question, the forecasting. 7-day forecasting is available through Farms and through the API. I haven't added the documentation on it yet. I ran out of time. But I'll be adding that in the next couple days. This is using the NOAA's FRET forecasted reference ET product. And if you pass reference ET as instead of CIMIS or GridMet, you press FRET, you'll be able to get that data for 7 days into the future. If you try to query FRET for 2021, it's not going to give you anything out. It's only a rolling 7-day archive. So just a thing to note there, Forrest.
Do you want to say a little bit about how you're handling the fraction of reference ET in those forecasts?
Sure. For anybody curious, under the hood, forecasting is a really complicated endeavor. We have internally played with a lot of different machine learning algorithms, different large-scale genetic optimization approaches, some of the latest and greatest transformer things, ARMA, et cetera, all the different methods of doing it. What our testing led to was that using what's called dynamic time warping, or this is used for speech pattern recognition algorithms, you can sort of do time series similarity analysis. So we can take existing data, let's say it's February right now, and I have some data, some ET data, and I want to know what's the rest of the season going to be like. I can look at what I have. It's going to run through all of the OpenET historical data as training data and find the most similar environmental, analogous year that's going to have the most similar conditions. And I'm making the assumption that, if my conditions are really similar now, and they're really similar in, like, let's say 2017, that it's going to be a very similar growing pattern. And so we use that to forecast seasonally the fraction of reference ET, and then we use the FRET product to actually calculate the ET.
So how far is it going back? 30 days or a year or?
So there are limitations currently for how far the OpenET data archive goes back in certain regions. Longer term, we're hoping to have just everything go back to like 1985 for the kind of the original like Landsat archive. That being said, in most cases, it's going to be 7 to 10 years, depending on like what type of historical data is present in the region.
But, and well, I think
No,
the last
my
question, we're
question
using
is
the
a
year
little
to
bit
date. So we're using the calendar year to date.
Yes, sorry.
As the default.
Yeah, but the question is, in order to predict the next 7 days,
Yeah.
will you look at the pattern of the previous week or the previous 2 weeks or so forth?
Right, so right now, going back to January 1st is the default,
Oh, it
but
will-
we can make that a parameter that the user can set, right? So if you're growing winter lettuce in Yuma, then you might wanna go back and start November 1st, right?
Okay.
And then, but the default will be January 1st of the current calendar year, and then it'll use that chunk of ETOF observations and ultimately search through 35 years of data.
Mhm.
Or let the user say, hey, the last time I grew, whatever, sorghum was 3 years ago, so use the pattern from 3 years ago,
Okay.
as a way to then, and then the time series warping is beautiful.
Mhm.
So I just want to kind of open just questions, and also thank you. This is really amazing to be up here and just seeing like a lot of people that are interested in getting ET data and interacting with the API. This is beyond my wildest expectations of what I ever expected this to be. So just thank you as the community. And just a note that we are very open to feedback, and we really want to know what would help you. Because, I mean, between Alberto, Jordan, and I, we can build most anything at this point. So if there's things that you would like, we really want to hear about that. And, if there's things we can improve on, please don't hesitate to reach out and know where to find us at the conference. And I see a question in the back.
Yeah, first of all, thank you. Love the UI and love all the work that you've obviously put into this. Really appreciate that. I had a question about, you just mentioned extending back to 1985. That's really exciting. And is it too early to say when you think we might get to that point?
I'll say we're reviewing data now for Oregon and the upper Colorado River Basin. Utah and California are next on the list, and then as soon as we can get through the review for each region, we'll be adding that for the public data collections.
Yep.
So we just need to give the science team time to review and the partners time to review. So you'll see some of those data sets start to come online later this year.
Following on that question, is there an experimental way to just, for any user to test a specific area of the country? Like, let's say I want to go to this area and run OpenET using Landsat 5, or is possible?
The code is there open source, so if you have an Earth Engine account, yes, you should be able to take a copy of the code and then run any of the models for a region. It's extra work. There's not sort of a, run OpenET for South Dakota, or actually not South Dakota, run OpenET for, South Carolina. That it's not that plug and play yet.
Understood. But does the code support some possible difference with Landsat 5, or there is
Yeah.
need to be, it's already supported?
Landsat 5 is already integrated and supported, and that's what we're using for the historic data production.
Yeah, and just a note for maybe folks less familiar with kind of the Landsat ecosystem. 5 is something that's decommissioned at this point. So if you tried to run Landsat 5 for 2020, it's not going to work. Not all of the models are fully open source. We're working towards that. Most of them are. I think there's 1 or 2 that aren't right now, just because the code's getting cleaned up and we want it to be usable. you'll see Charles Morton in the back of the room. This gentleman is, he's the one kind of handling, is the data behind OpenET data. He's the one who runs the models and interacts with those. So if you have any kind of really model specific question, or how do I go to the OpenET GitHub and run these, he's a wonderful resource to ask, and is an absolute programming wizard. Question in the back there. Yes, so sorry, as short notice, you'll find those in the documentation at openet.gitbook.io, and at the very bottom you'll see conference slides. Yep. Yes.
So I just want to know if a particular field, polygon, was irrigated in a given year or not.
Yeah.
How would I extract that? Is there a way to do that?
We have talked about in the geodatabase itself adding an irrigation status. While that's data that we haven't collected and processed for all regions, that's something that we're looking to do. If you wanted to try to figure that out, I would pull the NDVI data or the ET data, and you can sort of create a visual map. And you could either do it in an automated fashion where you're looking at this region under this specific threshold of, say, NDVI, where you're kind of looking at the greenness level. If it's really low, 0.2, I can say that's not irrigated. There are ways to do that, but there's nothing built into the API where an irrigation status is fully assigned. Find me after. I've built a fun classifier on Earth Engine that classifies irrigation status, and it's about 88% accurate. Really surprisingly easy to do, to be honest. But that would be another way if you wanted to go that route.
Yeah, and then David Ketchum has done some nice work with EarMapper for 11 states in the western U.S., and then also looking at some of the land and other products as well as potentially. But right now, we're not including that.
Okay, yes, question and then question.
During the time series multi-polygon point of it, I think you mentioned something about the type of export to use for certain applications. Could you go over that one more time? Something about use this for application purposes?
Yeah, sorry. So I know this is kind of a sticking point. That it's a little bit one of the more confusing things in the overall architecture of the API. You'll see that there's the time series multi-polygon, and then if I scroll down, the export multi-polygon. The thing to remember is the time series multi-polygon itself, while ultimately the returns are pretty much the same, this that returns a direct time to live link can really only works for smaller regions. Under the hood, it's using some Earth Engine code that does a get pixels, which is great for machine learning things, but it's really computationally expensive. And so you run into memory limitations very quickly using that. If you want to do bigger things, and in most applications, I recommend just kind of doing the export version of this. It's a little bit, it's a two-step thing, but you can do drastically larger areas and more complicated operations. Those are the main difference. Yes?
My question is, how much can I do before I run into problems? You have used up all your space or whatever, and if that happens, what can I do?
Yes. So at this time, you'll see in the documentation page this little section called quota. It's very much under construction. Whoops. Well, so in this room, there are a lot of actors that might be interested in just sort of scraping this data and selling it off. So not inside this room. Sorry. I'll give. I mean, maybe. I'll give you the tools.
You gave me an idea.
We have just been hammered by people just trying to come in and abuse the system at times.
Oh, yeah.
So initially, you'll see that the API launched with a really conservative quota. 100 requests a month, 50,000 acres. Not, a lot to work with. It was designed for people to click around the Swagger interface and then I could link my application up to this, or I could do this. And that was it. We, from the beginning, wanted to provide much larger ranges of access. Because there's some complications with being a 501c nonprofit, having certain signing things with Google and all these other partners, ingesting money in from an outside source can have like legal ramifications. So how we go about adding those tiers is taking a little bit more time, just because you have to get lawyers involved and it's tricky. That being said, part of this conference is one of the things I announced was that that's a bottleneck for so many users, and it doesn't need to be. So it's kind of taking a little bit of the reins off of the API by linking your Authentication account. It just gives that base quota a 4x multiplier. So while your account's linked, you'll see that it's 200,000 acres now, 400,000 requests a month. It resets every month. So if you use those 400, right now you just have to wait till the first of the month, next month, and it'll just reset the whole quota. But we're hoping that that gives most developers more flexibility to be able to kind of build these like a little bit more scalable applications that they're working on. If you have any, come talk to me. Let me know what you're doing, and we can try to figure some things out. But the official tiered system hasn't launched yet, and it's taking a little bit more time.
And our goal there isn't, it's not to commercialize, it's just to recover some of the actual costs that we pay every month on Google Cloud, and then also try to make sure that no single user just swamps the queue. Right. And so if there are particular applications, we just want to work with folks one-on-one, and then figure out, is this something so big that it's better for someone to just pull data directly from their engine? Can we support this? And if we're going to support it, we want to make sure the code is written cleanly, and that we know who's doing it, and we know when they're hitting it, so that we can try to gracefully scale. And as we learn more and more from the user community, we'll continue to ramp up the quota. We just didn't want to start really big, have the whole thing break and fall down on our heads,
Yep.
and then have to apologize and start over. So we'll try to keep growing as we can.
Yep.
So with the SIMS data,
Yes.
are these downloaded as I could download the SIMS data from their website in California?
Yeah.
Or is there an additional quality check?
We're taking SIMS straight from the Spatial SIMS site because it's the official product. We found issues with the fact that especially during drought years, people are not watering the grass. That's just bare dirt. So we're working with the DWR team on trying to make some improvements and corrections.
Yeah, and one way around would it be that I download everything to OpenET,
You can.
and then also the reference ET,
Yeah.
then I can divide by the reference ET, and then put in my own corrected reference ET data
Sure.
after I correct the SIMS data. For
Yeah.
example, the radiation data sometimes are pretty mediocre. Okay,
Yep.
thank you.
I will say this API, from what I've heard, is much easier to work with directly than the SIMS API. I've heard it's a nightmare. I haven't done it personally, but I know there's a lot of folks interested in just using this to get SIMS data. Yes.
More of a request, future request.
Oh,
Sounds
please.
like you have a very busy couple weeks ahead of you, but I'm an economist, so I know just enough about APIs to be dangerous behind the wheel. What you just presented was like awesome, and I can't imagine retaining that 6 months from now. So if
Fair.
there's like in your future like how-to that just walks through exactly what you did with like I see that you have examples in here, but flushing everything out and like using this API for dummies, that would be amazing.
Absolutely. So we on the documentation, I have a series of like videos where I do just that.
Awesome. Okay, great.
They're very embarrassing, but you will find those on YouTube, and you will see my face talking code and just some interactive things. There are not many of them, because I hated I hated recording them. But I will be expanding that list because I know a lot of people have really gotten some use out of that.
Thank you.
But yes, absolutely. Yes.
Another application we've used is just kind of a map viewer of the annual ET data for a given year. And I noticed that there's no, like it's a great viewer on your web map, but there's no version of that in, say, ArcGIS Online. Is that a feature that's been requested? Is that something you could consider exposing?
One of the endpoints I didn't just talk about is going to be the dynamic tile cache endpoint. So when you load like different raster tile layers into an application, whether that's a base map, whether that's some environmental data, it uses something that looks like this. So I'm just going to run this just to show you the output. This endpoint takes in some parameters pretty similar, but you'll see that there's an option to sort of specify some color things, minimum, maximum values for color, and then some palette to colorize, what that is. This is really cool because you'll see that it gives a map ID, a token, and a tile, not the token, but the tile fetcher. And what this is, you can plug this directly into any type of mapping application. In Python, there's a lot of things of a library called Folium that's really popular with Earth Engine. And this plugs directly in and generates a full tile cache on a very large scale. And so that's a really cool thing to use. If you want an immediate look, one of the other visual endpoints you'll see is the visual animate query. So again, very similar, I can say for 2022, for this region of interest, for this kind of color palette. Let's take a look at like just a colorized PNG. And right here, you're just sort of seeing the standard OpenET color ramp, just simplified a little bit. I could take one of these links that it returns. That's right. And that's honestly happens so much more than you think. So this right here is generating just a GIF image for one image per month for a year of that region that I'm looking at. So I could just quickly visualize that. And then if I want those images themselves, which that's the link, you'll see the second link here actually gives you the film strip of those images. So this is a really nice thing just to, again, kind of at a glance, see what's happening. So yeah, I can sort of look at this and I can get those images out.
Well, we should probably take just one more question and then we'll wrap.
Yep, sorry, we're right just over time. Yes.
So I have kind of a specific question, like with experience with OpenET data.
Sure.
Have you ever received any feedback about like when you're trying to use API to get time series data from multi-polygon, the polygon between two overlapped ET data, they kind of fail. Have you ever received any feedback about that?
Could you say that second part again about when it's overlapped? Could you repeat that?
So for polygons that fall within like Landsat images that they are
Yeah.
overlapping, the API kind of failed. It doesn't work for that specific polygons. I was wondering, is it something, problem with my shapefile, or is it something that you receive feedback?
Yes. So the question is, in the remote sensing world, the satellite data has these images that potentially overlap, and if you try to request one region in those overlapped images, you can get like two images out or two numbers out. In your case, was the query failing, or was it giving you two numbers per polygon? You'll have to show me that. There are corner cases which I haven't caught. I tried to catch most of them, and because we have such a wonderful feedback community, people will point things out. So let me take a look exactly what that is. The API itself does an internal mosaicing, so it'll like look for all images that potentially have duplicates, and then sort of mosaic the images together to create a single image per time step. And yeah, you do hit those corner cases surprisingly often, just because the way that the tiles are broken up is there's a lot of overlap. So yeah, come find me and show me that query, and I'll take a look. Could be something on my end, to be honest.
And after lunch, we do have office hours scheduled.
Yes. Office hours. So there'll be myself. It'll be Alberto Guzman, Jordan Harding. So come find us there if you have any questions, if there's anything that you want to talk about. Thank you so much.